Hey guys, I'm a science potato, and today I have another Cura video for you. Today we're going to be discussing the slicer settings found within Cura. And there are hundreds of settings, so we're going to try and quickly go through them all. So the important thing to note is having all of your settings visible. So if you click on these three little lines here, you can set your setting visibility to all, and now every single setting found within Cura will be made visible to you, so you can see everything that's affecting your prints. It's important to note that if you click, say, Basic, and you can see a bunch of the settings have disappeared, all of those settings are still active even though you can't see them. That's very important to note. Regardless of whether or not you see them on this list, they are there and they are active. So we'll select all, and we'll start in our Quality tab here. So here we have our layer height, our initial layer height, and line widths. So our layer height is of course the vertical thickness of the layer put down by the extruder. The initial layer height is the same as the layer height, but only for the very first layer. Sometimes it's better to have a thicker first layer, because that can help compensate for a little bit of a skew tilt in your build plate, having that thicker first layer there. Then for our line width, I have it set to 0.5, which is the default we use with a 0.4 millimeter nozzle. It makes designing easier as well because you can design in 0.5 mil increments and know you won't get little gaps in between your walls. But of course we can set this to whatever value we like. Most 0.4 mil nozzles, assuming they're using the standardized E3D geometry, a 0.4 mil nozzle can print a 1 millimeter line width, which we've done plenty of times at the shop, but usually our default is 0.5. Now we can see that underneath line width we have many more line widths. Wall line width, outer inner wall line width, but you'll notice that they are indented. That means they're a subsetting of the setting above it. So the main setting is our line width, a subsetting of it is our wall line width, and a sub-subsetting is our outer wall line width and our inner wall line width, as well as top bottom, infill, skirt brim, initial layer line width. So because they're all subsettings, if we change the main value, all the other settings will change with it. Then we have our shell tab. So here it's important to note a few things. We can see we have wall thickness and wall line count. These are both the same variables given in different ways. And it's important to note that because say you use a 0.5 mil line width like we do, if you notice our wall thickness here is 0.8 millimeters, how is it supposed to make a 0.8 millimeter wall using 0.5 millimeter line widths? It can't. If it was 0.4 mil line widths, then a 0.8 millimeter wall would equal 2 walls printed. It's much better and cleaner to use the wall line count variable instead of the specific wall thickness. Because with a wall line count of 3, it doesn't matter what our line width is, there will always be 3 walls. So with a 0.5 mil line width, 3 walls would be a 1.5 mil thick total wall. But if we were to up our line width to 1 mil, all of a sudden these 3 walls mean a total wall thickness of 3 millimeters. So maybe we'd want to cut back to 2 walls or even 1 wall instead for a real quick prototype. Then we have some other settings like an outer wall white distance, and a lot of these variables don't really need to be touched at all. You really want to try to use the least amount of variables to get the best quality out of your printer before you start putting band-aids on band-aids on band-aids to try to fix things and you're not really sure what's going on. So a lot of these values we try to keep them off if we can. And then just like with the wall thickness and the wall line count being 2 of the same variables given in different ways, we have our top thickness and top layers and bottom thickness and bottom layers. Where same thing, we never want to specify the specific thickness, because with the top thickness of 0.8 but a layer height of 0.3, how is it supposed to make a top area that is 0.8 millimeters thick with a 0.3 mil line width? Or sorry, that's 0.8 mil, yeah, with 0.3 millimeter layer heights. So instead we use specific top layers and bottom layers. So now no matter what our layer height is, we will always have 5 top layers. So if you have a 0.1 mil layer height, your total top layer thickness will be 0.5. But because we're using a 0.3 mil layer height, our total wall thickness will be 1.5 millimeters. And this is much better to use specific values than things that are left, up in the air and rely on other settings to be tuned properly to these settings. Then we have our top and bottom pattern, and zigzag is honestly the best. Zigzag is great because the way the toolpathing works, there's no travel moves at all, which is really nice. Although, that being said, the top-bottom pattern, it's not super critical. Lines and concentric can work, but honestly, zigzag is the cleanest, most reliable way to go. Top-bottom line directions, so normally they're placed on 90-degree grids, and with this variable here, you can rotate that grid. So if I set this to 45, now my top and bottom line directions will be rotated 45 degrees rather than the straight path they normally take, which can be useful in some situations. Outer wall inset, if you aren't getting proper alignment between your lines, again, this is more of a band-aid, so we try not to use it. That's why it's off, because we've tuned the printer to work without needing it. Optimizing the wall printing order is pretty good, specifically because you generally don't want to print your outer walls before your inner walls. Usually, the best way of producing a layer is to start with your inner walls, then your outer walls, and then your infill. That usually gives you the best setup. Doing your inner walls first means that you won't get bulging as those walls come around and hit your infill if you had done your infill first. If you do infill, then your inner walls, then your outer walls, those walls will be bulged out where those infill patterns hit and connect to that wall. So if you do your inner walls and your outer walls, you have no visible bulging caused by your infill, so it gives you a cleaner print, and then you can do the infill afterwards. You can also alternate extra walls to put in extra, say your walls are set to 3, every other layer it may add a 4th wall, and then back to a 3rd, and a 4th, and a 3rd to help more stability. Again, if you need it, but usually you want to use the least amount of variables you can. You can also compensate for wall overlaps as well, but again, you can see in our settings we don't need any of this. I've tuned these settings very well over the years. Fill gaps between walls, usually you want this off. And sometimes people use it, but honestly, it does not produce good toolpathing at all. If you look at the G-code viewer, you will see that the toolpathing produced by it is very splotchy and gappy. And the reason there's gaps between walls is because the wall thickness, the line width you are choosing compared to the amount of walls being used is not optimized for the dimension of the model itself. So a 3.2 mil thick wall printed with a 0.5 millimeter line width is going to leave a 0.2 millimeter gap in there. And that's something you want to try and avoid. Instead of making that wall 3.2 mil, if you had made it exactly 3 mil with a 0.5 mil line width, that perfectly divides in, meaning there will be no gap between those walls. So the best you can do, if you did not design the model, you cannot adjust those dimensions. So in that case, your options are adjust your line width to produce a value that fits within that dimension, or you can use the next setting here, which is our horizontal expansion. This is basically a tolerance value that you can use to make very, very slight adjustments to your part. So say you print a block with a 50 millimeter hole in it. You print it, but instead of that hole being 50 millimeters, it's 49.8 millimeters. So it's very, very close. It's only off by 200 microns. In that case, rather than adjusting your settings in the design, you can just adjust this horizontal expansion value. You could set it to negative 0.1 because this is on the radius. So a 0.1 reduction on the radius will give you a total of 0.2 millimeter increase in diameter. So that 49.8 will now be exactly a 50 millimeter hole. And you can use this to adjust walls as well. So like I said, if you had a 3.2 mil thick wall and you're using a 0.5 mil line width, you will have a 0.2 millimeter gap in that wall. So if you set your horizontal expansion to negative 0.1, it will reduce that value by 0.1 on each side for a total of 0.2, which will completely seal up that hole, giving you perfect lines and perfect adhesion. Now by default, we have it set to negative 50 microns to counteract the little bit of expansion the heat causes in the plastic. But we can tweak this variable as we need. There's also initial layer horizontal expansion, which is that same variable only for the very first layer. So this is for that elephant's foot that everyone talks about. When you get extra squish on that first layer, well, you could set this to say negative 300 microns, say. And now when it squishes in, that first layer will be offset just a little bit so that extra squish can line up with the next layer above it. There's also horizontal expansion just specifically for holes, which is a pretty new feature. Then we have our Z-seam alignment. This one's important. All 3D prints have a Z-seam. There's nothing you can really do to get rid of it. The best you can do is tune your printer and your settings really well so that it's as least noticeable as possible. So by default, we have ours set to shortest, but that may not be the best for what you want. So you're doing sculptures and you want the sculptures to be viewed from the front. Well, you can tell Cura where to position your Z-seam. So you can go user specified. Now it gives you an X and a Y position on the build plate where it will attempt to place that Z-seam. So you can place it on the back of your part so people won't see it. You can also go random, which honestly, I never recommend this. You will see a lot of people online recommending using a random Z-seam, but honestly, you do not want to do it. All those little dots caused by the Z-seam will now just be spread throughout the part, and it'll look like your print has pimples or chicken pox or something. It just looks really bad, and honestly, there's no real good reason to use it. The best one, in my opinion, is sharpest corner. The reason for that is anytime you have a corner, whether it's an obtuse or acute corner, and that Z-seam is placed directly on that corner, it's basically invisible. That is the best way to get rid of your Z-seam, is to have a corner where it can be placed, because it'll never get noticed on a corner. So you can tell it to hide the seam, or expose the seam, or do either of them, or use smart hiding where Cura has some code built in where it tries to figure out a good place to do it. But usually going sharpest corner, hide or expose seam, or the smart hiding is an awesome way to go if you're concerned about your Z-seam. Now, skin and Z-gaps is more for sometimes if there's issues with the model where there's extremely small gaps in the file, and Cura will ignore them really than seeing them as truly being there. Extra skin walls, so anytime your print is going to do skin layers, it will produce an additional wall to help the edges of those skin layers stay adhered and formed properly and not sag or lift up. Ironing is another setting where it basically goes over your final layers one additional time with drastically reduced extrusion to give you a nice, smooth, flat surface. Skin overlap percentage is another really good one. If you ever notice the tops of your parts have little holes right around where the skin and the walls connect to each other, that is because of this value. This is the value that tells the skin layers how far to press into the wall before turning around and going back the other direction. So for our default here, it's set to 14, but I've recently actually increased this value to 30% of the wall overlap. That really helps. Our 0.4mm nozzle printers haven't had an issue, but our 0.8mm high flow systems have had a few times where their walls haven't connected. So now that I've upped the skin overlap percentage to 30%, that is no longer an issue, and it hasn't hindered any of the other machines either, so we're leaving it at that value. And of course, this is a percentage based on the line width you're using. So it's going in 30% of a total line width, which is 0.5mm. And that's just our shell tab. Like I said, there's a lot of settings here. So for infill, simple infill density, I recommend 0 to 30% is a good range. Once you get higher than 30, honestly, you may as well just be using 100%. Infill pattern, there's a huge range of patterns here, but I'll tell you, the best ones in terms of efficiency and reliability for real production work is zigzag. Zigzag's the best. Zigzag connects all the lines together, so the entire infill is done as one single extrusion. So there are no retracts or travel moves unless they are required, which is real nice. Although Cura has recently added the ability for many other infill patterns to also follow those same rules. We've always gone with the zigzag. And it's nice because it only does one direction per layer, which means it looks a lot denser. A 30% density with the zigzag looks way denser than 30% with grid or lines does because of that. So we like that. We get good stability and reliability out of our printers using the zigzag pattern. And honestly, most of the other ones, I've never really had to use them. We're more concerned about reliability than anything. Reliability and clean, consistent prints. Zigzag's just the way to go. Infill line direction. Again, your infill pattern is always at a 45-degree grid, but you can change the rotation of that grid using the infill line directions here. So you could set this to 45 to change your directions for certain reasons if you may need to. More settings here that we just do not use. We do not need infill offsets. We don't need to randomize our infill start. It's fine. Extra infill wall counts. Honestly, there's no reason to use that. Infill overlap percentage. So it's how the infill connects to the walls. We got a bit of an overlap. This is honestly probably Cura's default value. It's fine. Infill wipe distance. Again, more default values here. Just a hair of an infill wipe distance. Not a real big deal. Infill layer thickness is going to follow whichever setting your layer height is set to. Gradual infill steps. If you're doing huge parts and you really are concerned about your material use, this will reduce the density of your infill the deeper inside of the part it gets. So this can help save a lot of material on very large prints. Infill before walls. Honestly, you never want to do that. I said you always want to do inner wall, outer wall, then your infill. You may have a reason to use your infill first, but generally not. Minimum infill area, the smallest amount of area. We have it set to 0, so any area that can fit infill, it will put it there. But honestly, this could be set to a value bigger than that, so very small features don't even get infill put in them at all to increase the efficiency of your printer. Skin removal width and skin expand are pretty good. So say you print a cylinder, and then at the top of that cylinder is another smaller cylinder. Well, that smaller cylinder has to be printed on the flat of the cylinder below it. And if the skin layers of that cylinder only go to the edge, there may be big voids inside and they may not connect properly. So a skin expand will press your skin deeper inside of the part after it's gone past your walls. And that's really good to get nice clean prints if you have a large surface area. And same with skin removal, that can be good on overhangs or angled features where it's putting huge amounts of top and bottom layers because it's an angle. And you want to get rid of that. You can waste huge amounts of materials and time because of that. So we have this turned on. And I'll adjust this sometimes. And honestly, you can save tons of time, print time and material with your skin removal width set to a proper value for whatever you're printing. Other few settings here aren't super important. Material settings, it's all temperatures here mostly. We got our different print temperatures, a few build plate temperatures, all our different flow values. Flow values, honestly, we never change. You should have your E-steps set perfectly, and you should never have to adjust your flow. Then we got our speed. These are all speeds in millimeters per second. It's very important to know that these are all very defined values. Infill speed is specific. Outer wall speed, inner wall speed, those are very specific speeds. But print speed, this is not specific. This is vague. What does print speed mean? Print speed is not a speed value. If you change this value, what it does is it changes the other speeds in relation to what you've set this speed to. So if I set this to 100, it's not really changing my speeds because I've set them all, but it's not actually going to print at 100 millisecond. What it might do is it might print your infill at 100 millisecond, maybe your inner walls at 80 millisecond, your outer walls at 50 millisecond. That's what it's going to do. So honestly, I recommend hiding this value. I'll go over here, click on this gear, find the print speed value, and hide it. So now the speeds here are the very specific speeds, and I'm not going to be confused or make a mistake because I see that print speed value. We have really fast travel speeds. You can take a look at all these speeds here. Travel speeds can be real fast. Why not? Most of our print speeds are set to relatively safe values. We don't want to go too fast. because we don't want to damage the machines, cause unnecessary maintenance, or ruin the quality of a print. We would rather print a little bit slower to get that assurance, reliability, and quality from the printers. Although you can print faster, we've easily printed at 100 millisecond, but our initial layer speed is actually quite fast at 25 millisecond. I've done even faster with really big nozzles. You can easily do your first layer at 50, 70 millisecond if you got a beefy enough system for it. We also have acceleration and jerk values enabled within here. So normally these are firmware values that can only be changed in the firmware or on the controller in your printer. But in Cura here, it just generates some G-code for you and you can set your values. If you've ever noticed Cura's print time is off, this is why. Because you have not turned on these variables or you have not set them to the correct values that your printer uses. And that's why Cura is not accurate. Cura is always very precise when you tune it properly to your printer, and these are the settings you do that with. Travel settings, mostly just retraction variables here, and retraction's pretty important. Lots of people tweaking all kinds of settings on here, but the big ones is your retraction distance. We retract very small amount, 600 microns. The speed at which you retract, so how fast do you pull the material out, how fast do you reinsert it back in. You can see we go very slow, which we can do because 600 microns of retraction is so small it's basically instantaneous. We have retraction extra prime amount. This is where it pushes extra material through the nozzle when the retraction ends and it reinserts the filament. That helps build up pressure inside your nozzle again so you can extrude right away so you don't get gaps after a travel move. Then we can tell it how far it'll move for a retract and how many retracts it will do within a certain amount of time. This helps prevent lots of retractions in very small areas. We can tell it where we want to start our layers and our Z-hop. I always recommend doing a Z-hop generally equal to 1 layer height. So for us, that's a 0.3 mil Z-hop. Now that's pretty tall. A lot of people do very small Z-hops, and honestly, if you're doing less than a 0.1 Z-hop, kind of why bother? If you're using a 0.1 layer height, that's totally reasonable, but with a huge layer height like 0.3, you should be doing a big Z-hop. They're super fast anyways. Then we got our cooling variables. I built a custom cooling solutions for our printers, and 100% fan speed is too much, so we usually cap them at 70% fan speed. We have our initial fan speed, which is 0, so it's off. Then at layer 5, it ramps up to regular fan speed, so effectively 20% increased fan speed per layer up to layer 5. Starting from your initial fan speed. We have a minimum layer time of 8 seconds. So if we're printing something small, it's not going to go super fast and melt it. It will slow itself down to make sure it does not complete a layer faster than 8 seconds. And as a balance to that, we have our minimum speed, which is 10 millimeters a second. So if we are printing something small and it hits this 8 second threshold, it will not move slower than 10 millimeters a second. And there's a lift head option, which honestly, no, it's old. You never need to use that. Support material, I have a video on supports, so I'm going to skip that. Build plate adhesion, pretty simple. Usually a skirt's default, or brim is what you're going to want to use to really help your part stick to the build plate. Raft honestly is outdated. I've never used one in years with our whole print farm running, so it's just a waste. Dual extrusion we don't have, so I'm not going to talk about it. Mesh fixes here, if you download files off the internet and people don't really know what they're doing and your file's corrupt, here are functions that can attempt to fix your 3D model. You'll just have to play with them to see what they do and if they can help you, but they have helped me in the past. Special modes, a couple things in here. This is where you'll find spiralized outer contour, so you can print without a Z-seam. Really only works on cylindrical objects like vases or single layer prints. And then there's some experimental settings. Most of these settings aren't super important. Fuzzy skin's pretty good if you don't want the super smooth features of a print. If you want a texture to it, like ABS sheets, for example, have that nice texture, you can turn on fuzzy skin and it will slightly jiggle when it prints your outer walls, giving a nice texture to your parts. Use adaptive layers. If you want Cura to change layer heights based on the curvature of your parts, it can do that. It can change the layer height every single layer using adaptive layers here. If you turn it on, more settings will appear, so you can tweak those values. So if you have a really curved feature, it'll print at a very small layer height, so those curves looks nice and smooth. But then when you get to straight sections, it'll switch to a taller layer height so that it prints them faster. It's a really nice feature. And a couple more experimental settings down here aren't super important. There, we did it. We got through the whole video. That was a lot of settings, and I think we'll cut it here. Thanks for watching. Hopefully this helps. And remember, all of these settings, they have descriptions on them. You can load in a model. You can look at your preview mode. You can analyze the slice. You can visually see the changes you've made. So if you're unsure what a variable does, just change it and look at your preview mode and see how the G code has changed because of it. And you'll just learn more and more about how the system works, and you'll get better at it as well. All right, this is Science Potato signing off. Thanks, and I'll have more content for you soon.